Now let us move on to a universal statement. Existential statement, they're easy to work with. So let's write down one example here. So we have this statement. The statement says, for any integer like n, if n is even, and n is bounded between 4 and 26, then n can be written as the sum of two prime numbers. Two prime numbers. Very well. So what do we have here? First of all, we have a universal statement. This is a universal statement. For any x in D, for example, qx. To prove the universal statement, if you have finite numbers of values in your domain, then you need to check for each one of them. To prove a universal statement with finite, limited numbers, we need to check for each number. Okay, very good. How many even numbers are in between 4 and 26? Let's check. So let us start by 4. 4 can be written as 2 plus 2. That is satisfy the sum of two prime numbers, of course. What about 6? 6 is 3 plus 3. You're fine. What about 8? 8 is 3 plus 5. You're done. What about 10? 10 is 5 plus 5. What else? 12. 12 can be written as 5 plus 7. What else do we have? We have 14, which is 11 plus 3. Then you have 16. 16 can be written as 5 plus 11. What else? 18. 18 is 7 plus 11. Then you have 20. 7 plus 13. 22. 5 plus 17. We have to stop at 26. We still have 24. 24 can be written as 5 plus 19. And finally 26, which is 7 plus 19. So since the domain is limited between 4 and 26, we have to check for each number. We need to show that each number can be written as the sum of two prime numbers. So we just prove this universal statement. You need to check for each number, for each element, versus the previous examples that we had for existential statements. Existential statement, they only need one example, but universal statements, you need to check for each number if you have limited or finite numbers in your collection.